Electric current is the flow of charge. For example, the battery in a flashlight produces the current in a filament of the bulb. When these switches turn on, a variety of home appliances operate on alternating current. Current exists in a conductor such as a copper wire. Current can also exist outside a conductor. For instance, a beam of electrons in a television picture tube constitute a current. The amount of load depends on both the material through which the charges are passing and the potential difference across the material. Whenever there is a net flow of charge through some region, an electric current is said to exist. Charges in motion through an area. The time rate at which charge flow through the area is defined as the current I. The current is the rate at which charge flows through this surface. If Q is the amount of charge that passes through this surface in a time interval, T, the average current LAVG, is equal to the charge that passes through a per unit time. So the formula for finding average current is, if the rate at which charge flows varies in time, the current varies in time. We define the instantaneous current I as the differential limit of average current, and the SI unit of current is the ampere. If the end of a conducting wire are connected to form a loop, all points on the loop at the same electric potential, hence the electric field is zero within and at the surface of a conductor. Because the electric field is zero, there is no network transport of charge through the wire. Therefore, there is no current if the end of the conducting wires are collected to a battery. However, all points on the loop are not at the same potential. The battery sets up potential difference between the ends of the loop, creating an electric field. Within the wire, the electric field exert force on the conducting electrons in the wire, causing them to move in the wire, and therefore creating a current microscopic model of current. A battery does not supply electrons to the circuit. It establishes the electric field that exert a force on electrons already in the wire and elements of the circuit. Consider current in a conductor of cross-arc sectional area A. The volume of a section of the conductor of length x, which is the gray area of the conductor shown in the figure, is a xif and represents the number of mobile charge carriers for unit volume. In other words, the charge carrier density. The number of carries in the gray section is nax. Therefore, the total charge Q in the section will be, where Q is the charge on each carrier if the carriers move with a speed Vd, the displacement they experience in the x direction. In the time interval T is xv dt, so delta Q will be equal to, and dividing both sides of this equation by T, we find that the average current in the conductor is